Okay, today is February 6th, 2025, and this is another SIG scheduling meeting. Today we're just discussing DRA. Is that correct?
Well, we were discussing, so Dominic put out a proposal, and probably nobody's had time to read it because I think it was just yesterday or the day before. But maybe, Dominic, you can add it to the agenda doc just so people have a reference to it for later. And so we were just kind of discussing that, or where we might go with that in the long run. It's around using resource claims as a reservation mechanism. One thing, Bobby, did you want to see if we can understand you now?
Yeah, let's see.
Oh,
Is this any better? Okay. All right. So I was going to say that I think we are combining a few things together right now. Part of it is multi-pod scheduling. I guess this is one of the requirements. Reservation is another concept that we are adding to the mix. Maybe a little bit of a batch scheduling you are thinking about as well. I think we need to. I know that they are very much related to each other, but I guess it would be best if we can kind of divide them into smaller chunks and discuss them separately, because otherwise the problem can become super complex. Plus, there is always a chance, especially when it comes to reservations, etc., that we could end up having a solution that reduces resource efficiency. Because certain teams, for example, who are sharing a cluster could reserve resources and not use them. This is going to be pretty problematic in the new world where GPUs are very expensive. So yeah, we should I think first define the problem before jumping on the solution. Let's first define the problem clearly, and then we can think about the solution, because I think we are now kind of solutioning a little bit before the problem is fully defined and clearly defined.
So maybe the way I understand group and gang scheduling, it's the main purpose of that is when you know what kind of pods you want to run, then you probably are interested in how to make all of them schedule, guarantee that all of them are scheduled at once, and that they are like quite optimally placed, considering several different constraints. The reservation, how I understand it, is something a little bit more than that, a little bit different. So reservation may be sufficient to make sure that the group of pods get scheduled within this reservation.
Reservation is very different. Reservation almost has nothing to do with a group of pods. Reservation just keeps your resources, keeps guaranteed amount of resources for you. It could be one pod, it could be multiple pods, doesn't matter.
Okay. It's
a primitive, and it's a primitive. So, I mean, I guess we didn't go back and define all the problems here. Maybe we need to do that. Like, we jumped into the middle of the conversation, and so that's why we're sort of already talking about reservations have been emerging over the last few weeks and months as a possible solution to a couple of the problems we have. One is the group scheduling. Like, can we obtain a reservation across a series of pods? We don't have transactionality, right, in Kubernetes. So can we do it across a series of requirements in one request without it being bit by bit? So that's one aspect we think reservations might help with. Another is that we have this idea of different schedulers. Like Kube scheduler works pod by pod, but there are other schedulers like Slurm and other HPC schedulers that might look more holistically and come out with a whole plan that spans many nodes and pods at the same time. And so we see reservations as a mechanism whereby a second scheduler like that could operate on the same cluster, yet without causing race conditions or conflicts with Kube Scheduler, where basically if they both use a reservation as a coordination mechanism, right, then all of a sudden you can have both schedulers running on and managing resources on the same node without a risk of double booking something. As an interim step, just one more thing. As an interim step, the proposal, as Dominic wrote it, wasn't necessarily to get all the way there, but was to at least allow us to use a reservation to cordon off and say, hey, these nodes are managed by Slurm. And so that's like an interim step before we get to the bigger, like really reservation that at a low level can coordinate everything. Obviously, if we can get there just as quickly, we may as well do it, but I don't know that we can. So that's kind of a little more context for you, Bobby, if that helps.
It certainly does. Thank you for the context. By the way, reservation has been in conversation from the very beginning of Kubernetes because we have them in Borg, and I know that some people who were designing Kubernetes were not big fan of reservations because of some complications and sometimes a little bit of unfairness when you're sharing clusters. But what I'm hearing right now is that reservation, you are thinking about like reservations that are kind of allocated to different schedulers as opposed to reservations that are given to, I don't know, maybe a group of pods. Is that what you have in mind?
Both of those. So one is we can, I would say, I would wonder whether the same primitive could serve both of those purposes. But the first one, right, allocated to a scheduler becomes, then we need a concept of scheduling against a reservation, right? So one of the things we've talked about in DRA like this is, so here's an example. In 133, we hope to have functionality in DRA that allows you to represent what we call a TPU slice at Google. So it's like you've got, say, 16 nodes that have TPUs in them, and they all are wired together very fast, right, with an interchip fabric. And so you can use that whole 16 node block as one big thing, but maybe you only need 4 of the nodes. So we are building a thing in DRA to allow you to dynamically allocate a chunk of 4 that aren't in use. And so you have this resource that defines, say, one of those chunks that's 4 nodes. Once you pull that out, right, the first pod that comes in, say you've got a deployment with 4 pods, it comes in, the first pod allocates that 4 node chunk, and then individually each pod needs to allocate the TPUs on those individual nodes. And so right now, we sort of put it on the user to be like, I'm only going to create 4 pods when I ask for a 4 node subslice. But if the user did something stupid and asked for a 6 pods on their 4 node slice, and each pod can only fit on a node, like, we don't have any way to prevent them from doing that. It's just 2 pods would never schedule. So which might be fine, but the bigger point is that I think there are use cases, and this is one where you may want to allocate a set of nodes and then secondarily schedule a bunch of pods against it independently. Right now, it's sort of up to the user to construct the shape of this deployment or stateful set or whatever it is really carefully so that we don't screw things up. But so there's what I call user-mediated sharing. The user is making the decisions about how things are shared. But if we could do, in other cases, we want to do platform-mediated sharing, which is analogous to what pods do with nodes today, that the platform decides how to share the device. If I want to do that with a resource claim that I've sort of like said, okay, now I've got a 4 node thing, and now you can schedule a whole bunch of pods against that, and each pod will individually claim different numbers of TPUs. So it's not a pod per node in this case, but it's still all within that 4 node slice. I can do that today, but I don't have any controls like over that secondary. I don't have very good controls over that secondary scheduling, I guess. So I think Kevin at NVIDIA has some similar use cases around shared GPUs. He had originally proposed this idea of linked claims a year or two ago in DRA before all the changes we've made. So that the use cases aren't clearly and crisply articulated, but I'm seeing sort of evolving needs for this and trying to understand them better. So anyway.
Okay, yeah, thank you for explaining this. Yeah, it's a valid use case, of course, but needs a little bit more thinking.
Yeah, that's kind of that first one, right? It's like blocking it off for a separate scheduler or blocking off pieces of it for a secondary scheduler. But then there's also, hey, we want to reserve 2 gigs and 1 GPU and 1 CPU on 40 nodes. And we don't want to do pod by pod scheduling and then get to the 39th node and not be able to satisfy that last pod. So we want to hold on to it right up front and say we've got all 40. I don't know if the same primitive can do that, both of those things. That's kind of the discussion. Part of this.
Yeah, thanks. Yeah.
Right. So in this sense, a reservation could be understood as a resource allocation to run either basically a set of pods. But we can think about reservation as something that is prepared by someone, by a human, who knows what exactly the workflow will need, and someone needs to think what are resources that are needed, and then we have guaranteed that some group of pods will have all the necessary resources they need. But if we have more and more type of resources and very complex dependencies between them, so as John mentioned, we have nodes which are interconnected because they share the same machine and they have a fast connection between those nodes. So in some cases, it will be very hard for humans to to allocate such a reservation somewhere. And this is why using dynamic allocation could help us to make the reservation that is needed by some workflow in the optimal place instead of thinking in advance where it should be placed.
Yeah, reservations are generally very useful for the cases where you don't know at the moment what kind of future pods, for example, or resources you need, right? So you keep these reservations for sort of guaranteed scheduling in the future. This is usually under a certain amount of quota so that people do not go like crazy, like I want the whole cluster reserved for me, etc. So that's really helpful for those cases. For some of the cases that John was describing, I think the reservation may not necessarily be needed. We actually want to, if we were able to look at multiple pods at the same time and say that, okay, I'm going to find either resources for all of them, or I'm not going to schedule any of them. I think that would have solved the problem. Isn't that the case?
So I think that's the case, but we don't have a mechanism to hold on to those resources while the pods spin up.
So yes, that's a slightly separate problem. For example, let's say that tomorrow, magically, I add some new fields to a deployment and say that, okay, this deployment as a whole requires 40 gigs of memory and 40 CPUs and 20 GPUs, whatever. So the whole thing can be described, and then individual pod resources can also be described somehow. That would be enough, right? So a scheduler could look at that whole thing and say, okay, can I find this? Can I fit this whole thing in clusters and find enough on individual nodes, enough resources per pod? And if so, yes, that's good enough. So I can schedule this thing. Now, would that be enough?
Well, but finding a place is the one thing, but the second thing is preparing the place. So you might need to preempt some other pods, wait until scheduler or someone evicts those pods, and once it happens, you want to make sure that this reservation is kept. Also, auto scaling might be involved in it. So we need to wait until the autoscaler kicks in and we reserve this place. And now we let the pods to be scheduled.
I see. Yes, both of
Yeah.
them are valid use cases. Yeah.
Yeah, so that's a good point. If we have autoscaler coming in, we want autoscaler to be able to pre-reserve the space on the new nodes that it's spinning up that are needed for the demand. That's a really good point. The other thing I wanted to mention, Bobby, you brought up the idea of fairness. So talking with the Slurm folks, the way they deal with that today is they have it's sort of like what Q does, and so this is where something like Q I think comes in, where you have for that fair use, fair sharing. What do they call it? Fair sharing, I think, and they do something similar in Slurm to what Q is doing, where they have duration estimates for workloads. So like, let's say you are going to run some big job and it's going to take 1,000 nodes. But there's another job running right now that's higher priority. You can't preempt. And so you're going to wait. Well, what they'll say is, okay, that if we were to not schedule anything new, then you'd free up at this date, and they lock that date in for you. And then in the meantime, they're like, okay, we'll take smaller jobs that will fit and then have shorter durations, and we'll backfill on all those resources and let it use it. It's very similar to what I think Q is doing when they talk about borrowing quota from different people, from different teams and things. So whatever we do for reservations, we would want to make sure that we can support that kind of use case in the long term to prevent the kind of sharing issues, fairness issues you're talking about.
I would go a step beyond and say not to implement this in scheduler, but make it interface with Q.
Agreed. Yeah, we should. Yeah,
because the APIs to define fair sharing are it is a lot of work just to define what is fair in a particular organization, and we don't want to repeat all of that work again.
What I would want to understand is what primitive can Kubernetes offer upstream that makes it easier for us to implement these things over the top, but not implement.
Yes.
Yeah.
Yes. There is something that kind of helped Q implement some things was the concept of scheduling gates, in which Q or some other controller can say, this is what I want, but don't try to schedule yet, because I'm waiting for my own quota to be satisfied. And only once Q says the quota is satisfied, it can go through. However, the situation becomes way more complicated when we talk about preemptions, because Q might want to preempt some jobs based on the fairness, but it doesn't necessarily know that preempting particular jobs will help, because those jobs that Q preempts might be, I don't know, fragmented or something like that. So your new job doesn't actually fit, even though the quota would allow it, but the capacity wouldn't. The actual allocations wouldn't allow it. So that's where it becomes hard to do this interfacing. because Q is the one who needs to make the decision from a fairness point of view, but it doesn't know about nodes or and the other way around. The
But
scheduler
Q might
knows about
try to
nodes but doesn't
schedule
know
them.
about quotas.
But I think the idea is that Q may try to schedule a group of pods and get feedback from scheduler saying what kind of pods scheduler proposed to preempt to place all the pods. And based on that, Q could make decision how to and influence somehow a scheduler to try to allocate it differently. For instance, okay,
Yeah.
I
I would love to see this kind of proposal being explored more. Yeah, although it's not that simple. DRA was trying to do something like that back in the day when we had the scheduler asking the driver who to preempt or who to preempt. Yeah, I think so. Then the driver would like reply back with a set of candidates, and then the scheduler will have to reply again, and then it could be an infinite loop
I don't think we
between.
got the preemption. I don't know that preemption was ever implemented, but I think they did have.
It was not quite preemption,
But there was
but
a coordinated, negotiated list of possible nodes.
yes, yeah, it's not that simple, but it certainly needs to be explored. That, I mean, that's one avenue.
So the other thing we've talked about a little bit is a sort of scheduling request or plan API, where um, if if we if we moved if we decoupled kind of the binding actuation piece from a lot of the decision making, um, then you could make decisions across a series of pods in one go and publish a single plan, a single resource, right? It gets back to non-transactionality in Kubernetes. But you publish a single resource that's a complete plan for a series of pods against a series of nodes. And then the fact that the actuation doesn't happen um, simultaneously is not a problem because the calculation is done only on plans. So, like the scheduler, rather than looking at um, uh, as it goes through pod by pod, rather than making those calculations, where does this pod fit? The scheduler would do those calculations against not only what's out there, but what's out there plus what's planned, which is kind of what it does already internally in a cache. But this would be put in the API server in such a way that multiple agents can use it to coordinate, as opposed to it being.
So this is exactly what I was thinking as a dynamic reservation.
Oh, okay.
So when you know the set of pods, you can try to schedule them in scheduler, but scheduler is not binding them, just trying to put them in internally in a cache. It will know what kind of pods would have to preempt to feed those pods, and in fact, the resources that the scheduler will have to allocate will become either what I call the reservation or what you call a plan. That would be exactly the same thing.
Okay, interesting. Okay.
So
I am actually not 100% sure if they are the same thing, because what I understood from what John said was that these are, look at a number of pods at the moment, existing ones, and create a plan, not per pod, but for the whole group of
yeah,
existing pods. But what you are saying, Dominic, I think it's more like a reservation. Some of these pods or even some of the nodes may not exist at the moment in the cluster. So you want to start with, some of the nodes are not available. Let's start with, looking at the available stuff, create a reservation on the available things, wait for more nodes to be added in the future, etc. So isn't that what you have in mind?
Actually, what I meant by a plan was not existing pods necessarily, or even existing nodes. It was literally like if we combine the autoscaler logic, like different schedulers. The idea is like, hey, we've got a bunch of workload demands. Maybe not even all the same workload, because mixing workloads means pods that might fit together more compactly. So like we look at, and maybe that means something different than what I'm. Anyway, so my point was separation of the actuation, that is the binding, and then
Yeah.
of course what flows from the binding, from the plan making, and then the the um, the plan making can vary. Different people can make different schedulers can make plans. Obviously, there's some. Sorry, I'm thinking too many steps down the road. The idea is you could have a scheduler that looks at your existing nodes and capacity, your potential nodes and capacity based on what's available to auto scale, looks at a set of workload requests, which may come in as a, maybe it looks at a deployment and says there's 50 pods in this. Maybe it looks at a random stream of things coming in and batches them. I don't know yet, but it uses that to calculate an optimal allocation, and then it can reserve with a plan that allocation all in one go, so that the next time it goes through a planning cycle, it doesn't, double book anything. Preemption gets super complicated. So I'm not sure how to do that, but I think.
Yeah, and we don't have the API for it either, right? So for like those streams and stuff like that, or like future changes, we currently do not have any API. Anyway, so there is a hand, I guess. Kevin?
Yeah, I'm pretty new to the whole SIG scheduling, so this might be a dumb question, but would this require like all workloads to use that reservation semantic to do that planning? Then,
I mean,
like pods, and then deciding whether something has like a certain lifetime or like is living forever, and like whether it's preemptible or not.
So I think that. So this is all just brainstorming, honestly, right now, right? Like we're kicking around ideas. I don't know that it's.
But I think I can answer this question actually.
Okay, go ahead. Yeah.
Because the reservation is an allocation that scheduler needs to do anyway, but like snapshotted and reserved. Because if you run a set of pods, scheduler needs to put them anyway. It needs to allocate the array resources anyway. But if it does it in one go, we don't know what will be the effect. Of course, in a sunny day scenario, all pods will get scheduled, either in an optimal way or not. And it will be a process. But if we do this process just a scheduler thinking, instead of doing that, we know whether what scheduler generated is good or bad, and someone may take a decision whether to bind, whether to just reserve the space for a future, or to abandon and maybe give it another try. Because it is one of the way to make more optimal placement of pods is to simply try several times to do the same thing, but with a little bit different beginning. So for instance, you could gather few such attempts, have a goal function, and pick the one that meets the, your goal the
Yes.
best, right?
Yeah. So I think, yeah, that's kind of the same as the way I think about it, Dominic. I think, Kevin, just to be very specific to your question, I think that what Dominic is saying is we could still allow all the existing flows to work. Under the hood, the scheduler would have to allocate this resource sharing / reservation thing in order to coordinate with things that are doing a plan. And so each pod that gets deployed through the traditional mechanism would be creating a one pod plan under the hood. And that's the coordination mechanism. And then as we sit down and we go, we could do a whole deployment at a time. Like we could have deployment create a plan for the deployment. There's so many different approaches, and I think it's going to require a lot of work to figure out the right way. If you look at something like Q, you can do way more because you can take two deployments that individually, one after the other wouldn't necessarily fit, but they might compact well together, right? Like there are I think that if you have time, because things are sitting in a queue, you could do more calculation to find more optimal compact placements. So the idea is to try to build the right primitives so that we can still continue to do the real-time scheduling we do today, but we can at the same time have these more thoughtful schedulers that run over longer periods of time and longer cycles and have them operate on the same cluster, which is the big challenge. And I'm not 100% sure we can do it even, but I think it seems.
Yeah, that makes sense to me. But the idea of having them represented on the backend scheduler side definitely it answers that whole question. Yeah.
Okay.
Yeah, and I think we need to notice one important thing. So currently, DRA covers GPUs and other stuff, but not covers CPU and memory.
Yeah.
But if it starts covering it, then such reservations could cover all demands that pods may have.
Yeah.
And actually, the proposal to make a node as a resource, as a DRA resource, is a way to simplify the thing, because in practice we are introducing CPU, memory, and other resources covered by DRA.
Yeah, it's a generalization of what we already do for Node, basically. Compute resources. So, although I guess this is scheduled for 45 minutes. What is I don't know what your usual conventions are here.
Yes. So we should be wrapping up. If there is no further comment, I have a quick announcement. Okay. So Kensei sent a PR to add an additional meeting targeting to be more friendly for Asia and Europe. And it is going for, let me see. It is going for 9 UTC, which is it the same as Central Time in Europe?
No, it's 10.
10 Central Europe. And what is it in Japan? Do you know? I don't think I know. Anyways, so
10 p.m., which is still quite late.
Okay. In any case, this was approved. I mean, there was a survey to establish this time, so this is what people voted for the most. Yeah, so next, it's gonna start next week. Yes, February 11th, and the link is the same. And that's all. Okay.
Okay.
Thank you, everybody. See you next time. Bye-bye.
Thank you. Bye-bye.
Thank you.